morning, students. Welcome to physics online class. Students, our today's topic is lens formula and sign convention. So there is an equation or formula which gives us the relation between object and image's position, and that formula is what we call the lens formula. So let me first write the formula for lens equation. Lens formula 1 by f equal to 1 by v minus 1 by u. Students, in this equation there are three unknown quantities: u, v and f. So u is represent the object, distance from the lens, and then v is represent the image distance from the lens, and then f is the focal length of the lens. Focal length. Let's consider in the case of convex lens. So first draw the convex lens, and then this is the principal axis, and then this is O, which means optic center, and then f1 to f1. So here f1 is the principal focus, and then right side f2 to f2. So where object is kept beyond to f1, so here we going to place the object. A, B is nothing but object. For image formation, we need to follow two rules out of three. So first rule, a ray which is parallel to the principal axis. So this is principal axis. So a ray which is parallel to the principal axis after refraction will go through principal focus. So this is first ray, and then for second ray, a ray which is goes through optical center O without any deviation, it continues, and then where the two rays are intersect is known as image. B dash, A dash. Students, now here it is the distance between. So we going to first find the f, because the formula is given as 1 by f equal to 1 by v minus 1 by u. So what will be the f here? So f is nothing but it is the distance between optical center or optic center O and the principal focus f. So f focal length is the distance between optical center O and the principal focus f is called as focal length. And then The distance between lens to A and B object is known as U. So the distance between object and the lens is known as U, and the distance between lens and the image is taken as V. Students, this lens equation is valid for all spherical lenses. Students, a lens formula like spherical mirror. So we have lens formula for spherical lenses also. Spherical lenses. So the lens formula gives the relation among distance of the object U, distance of the image V, and the focal length F of the lens. So it is expressed as 1 by F equal to 1 by V minus 1 by U. And then it is applicable for both convex and concave lenses. So we need to. Our next topic is sign convention. So sign convention for spherical lenses. The new Cartesian sign convention for measuring various distance in case of lenses are similar to the spherical mirror. Students, all the distance are measured from the optical center O. So first point, in sign convention, all the distance are measured from the optical center of the lens. And then according to convention, the focal length of the convex lens is taken as positive, and the concave lens is taken as negative. And then according to new Cartesian sign convention, the optical center O of the lens taken as origin, and then the principal axis. So this is the line called principal axis of the lens is taken as x-axis. X-axis. So here x dash x of the coordinate system. And then the object is always placed on the left side. So left side of the lens. Here we going to place the object. So object always placed on the left side of the lens. AB is nothing but object. And then light is incident on the lens from the left to right side. So this is a left, and then opposite is a right side. So the first one is the object is always placed. AB is object. So the object is always placed to the left side of the lens, and the light is incident on the lens from the left to right. And then our next point, all the distance measured to the right of the optical center. So this is the right side. Right side, and then this is the left side. So all the distance measured to the right of the optical center along x-axis. So this is a plus, positive x-axis, and then this is a negative x-axis. So all the distance measured to the right of the optical center along positive x-axis are taken as positive. And then while measured to the left of the optical center along minus x-axis are taken as negative. And then the height measured upward perpendicular to the principal axis along plus y axis of the lens is taken as positive, and then the height measured downward minus y axis. So minus y axis perpendicular to the principal axis of the lens is taken as negative. So this is a sign convention. So sign convention, Cartesian sign conventions are used for measuring the various distance in the ray diagrams of spherical lenses. So according to the Cartesian sign convention, first point, the object is always placed on the left side of the lens. Left side of the lens. Our second point, all the distance are measured from the optical center of the lens. And then third point, the distance measured in the same direction of that of incident light are taken as positive. And then the distances measured against the direction of incident light are taken as negative. And then the distance measured upward and perpendicular to the principal axis is taken as positive. And the last point, the distance measured downward and perpendicular to the principal axis is taken as negative. Sign convention. So this is a lens, convex lens. Principal axis and then optic center O. So our first point, all the object placed on the left side of the lens. Our first point, the object is always placed on the left side. So this is the left side and then this is the right side. So object AB is always placed on the left side of the lens. And then second point, all the distances are measured from the optical center O of the lens. So we have to measure from the optical center O. And then third point, the distances measured in the same direction as that of incident light are taken as positive. So consider the light source. So the light source is incident. So the light rays are coming this direction. So the distance measured in the same direction. So it will go like this. The distance measured in the same direction as that of incident light rays are taken as positive. And then the distance measured against. So against is nothing but opposite to that of incident light rays. So consider here convex lens, principal axis, optic center O, and then this is the object. So object always placed to the left side of the lens AB, and then the fourth point, the distance measured against to the direction of incident light rays. So opposite to that of incident light rays. Is taken as negative, and then the distance measured upward and perpendicular to the principal axis. So upward. So this one. The distance measured from the principal axis and it is perpendicular. So perpendicular is taken as positive. And then the distance measured downward. And perpendicular to the principal axis is taken as negative. So this distance is taken as negative, and this distance is taken as positive. So convex lens, the image is getting another side, right side of the lens, and it will be inverted. So we will measure the image size like this. And then in concave lens, we will get the virtual erect image, which is nothing but direct image, straight image. So we will measure the height from the principal axis and perpendicular to like this. So that will be taken as positive. So these are the 6 rules. First rule, object is always placed to the left side of the lens. And then second point, all the distance are measured from the optical center O. Either it may be U, object distance, or V, image distance. We have to measure it from the optic center O. And then the distance measured, same direction on that of incident light rays are taken as positive. And the distance which are against to that of incident light are taken as negative. And then the upward to the perpendicular principal axis taken as positive, and then the distance measured downward perpendicular to the principal axis are taken as negative.